So the next part of your lab says so you create a vending machine with one coin slot, with a coin slot that accepts a coin X and Y. Yeah. And it sends an output X when the coin is detected and Y when the other coin is detected. And then it displays the amount to the SSDs. That means you'll be using 1 digit because maximum number you can display is is 1 digit, is 9, so that means you'll be using 1 digit. So you have 2 coins, X and Y, and then you have a coin slot. That means it's 1 coin slot. So you put a number and then maybe press enter. That indicates that your coin is sent in, and then you put a number again and press enter, and then you send a coin. You must display that how much money you've sent in using an SSD. So even here, I'm not going to design this thing. I'm just gonna demonstrate how to what we expect you to do here. So since Lab 2 supports VHDL, the part of counting, of taking the part of taking 2 coins and adding them together, we are just going to do that using VHDL. So let me close that. No, don't save that. Save everything, close this down, and then open it again. That's yeah. Open it again. So you create a new file. So you create a new VHDL file. So yeah, and save it. Yeah, so you can call that a vending machine if you want. A vending machine. So yeah. And then you go to your hierarchy, set that as an entry point. Set that as an entry point, save it, and build it. Then build it. So what you wanna do, you go to this file, you go to files. You have to be careful here. Just follow carefully. You go to files, then create or update, and then you say create. What's this? Create a symbol for the current file. So it's going to create a symbol for the current file. So you'll realize. So what you do, create a new block diagram. If you go to your components, you will find that vending machine here. So this is your vending machine. Another thing you want to do, you want to go to your SSDs, BCD to SSD, same thing, go to your file, create, so you create a symbol for the current file. It's gonna create a symbol for this file and then save that, then okay, and you go back to your let's save that and say this is task, this is 2B, this is task 2B, yeah. Task 2B, this is task 2B. So since you've made your BCD to SSD, so if you've created your for task what's the task 2A, you can use this very same method if you want to use your your JK flip-flops. You can just convert that into a component that you're gonna use into something, because here so here you design a JK flip-flop, so you convert that into a component and then you use that component to on your sequence detector. So like here we've created a component, we've defined a component and then converted it into a block diagram that we can use on all the other objects. Same thing goes here. So this is a 7-segment display. You convert that into a component. It's gonna show up under the project. See, it's a 7-segment display. It's gonna show up under your components. So I'm not gonna recreate these things. You're gonna make them now. Yeah, and then copy that, paste that. Yeah. So here, this is your sum from your vending machine. Since you entered 2 coins and then it sums those up. What you call this is sum of outputs. So that goes from 3 to 0. And let's just put that below. Yeah, and this is what coin. This is coin that goes from 3 to 0. So that goes from 3 to 0, and then here. And then here, and then here you have your sum. Let me just copy that. Let's copy that. This is 3. Yeah. This is 3. This is 2. This is 2. This is Y. by the way, you can always do it however you like, as long as your pin configurations are fine and you can demonstrate your answer, then that's fine. I'm just making an example here on how you're supposed to do these things. Just want you to be aware of what is expected in the lab. So so your coin has 4 bits. Is a 4-bit input. So these are your inputs from the outside, from the user. Yeah, so like before, if you want to connect, like I said, this is a bus. It's 4 lines going from 0 to 3 to 0. If you want to connect line number 3, you just say coin 3. If you want to connect line number 0, just say coin 0. Same thing here. Sum of outputs 3 connects the line output 3 to the SSD and stuff, and this connects to the outside. These are the output that goes to your SSDs. These outputs, yeah. So these are your outputs from the LED. Like I said, you can design however you like. When LED when LED X goes on, this takes the output from the LED X for LED Y, and this is a Z. When both of them are on, then Z is gonna go on. In fact, when the sum is greater than these two, this is gonna go high. Reset, restart, those are switches. So yeah, save that, and it has to be set that as entry. Okay, this is convenient. This is really convenient. So I only need reset. I need coins. Okay, let's just build it for now. Let's just build it. Alright, and then go to your pin planner. Your pin planner, you're probably gonna need everything. So these are from your previous thing. Let's delete those. Delete. Yeah, Z. So obviously here you're going to need more than 2 LEDs. Do I have any other LEDs? No. So try this. So that's M3. From M3 you need M3, so M2 goes to bit 1. Yeah, this is M2, and this is M1, and this is L3. This is L3. Skip these two. Make sure even on your board you skip them, and then you use L1. This is L1. That's L1. So reset and restart. So restart will be switch 1. the one on your left, restart will be R1. Now restart, that's R3. Restart, that's R3. And reset, that's M9. And then your LEDs, these will be your LEDs. X will be R1. That's R1. And that's P4. This is P4. What about this one? So let's put this, I think, on L2. L2, because we've run out of LEDs. Let's just put this on L2. Yeah, L2. 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 So I've realized I didn't simulate this, so but it's fine. It's fine. Let's just simulate it and see how it works. New. Okay, and then this is always 0, and these are 1s, so you set those high, and then set those to 0. And then you bring that up for some time. Set the radix to unsigned decimal, so that's a 7 and the 2. That's a 7 and the 2, and the restart. Obviously, this is gonna depend on your design. But since we are going to be using switches, that means when we press the switch, it goes to ground. When we press the switch, it goes to ground. You should accommodate this on your designs. Where is this thing? That's okay. So I placed when you press, they go to ground. Okay, let's just move on. We'll see what happens when. Reset should set all this to 0. Should set all this to 0, and then a restart. That's your first coin, and then the next restart. That's the first coin. So like I said, you can do it however you like, but this is not a synchronous machine. It's just a parallel programming thing. Let's just see what happens. Save that, and then run that. Yeah. x, 0y. So 7 is detected, x goes high.